All right, we're at stoichiometry part 3 now, gram to gram relationships. We've looked at mole to mole relationships. We've looked at mole to gram and gram to mole, and now it's time to look at gram to gram relationships. All right, let's take a look. It says how many grams of oxygen gas would be needed, how many grams of oxygen gas would be needed to form 3.8 grams of water. So we're going to put 3.8, we'll circle 3.8 grams of water, we'll write 3.8 grams of water right there, and we're looking for grams of oxygen, so we'll write that directly under the oxygen right there. It's a 2 to 1 to 2 relationship, a very basic mole to mole to mole relationship, 2, 1, 2. And what we're going to do is we're going to take what we know, 3.8 grams, and place that over 1. 3.8 grams and place that over 1 times whatever unit's here is going to go right there, and we want to go we cannot go directly from grams to grams, so we're going to have to go through moles. I can determine the number of grams of H2O to be 18.02 by simply adding up 1.01 for the hydrogen times 2, because there's 2 of them, plus 16 for the oxygen. That gives me 18.02. So there's the relationship between grams and moles. So now grams will cancel out with grams, and I'm left with moles of H2O. The next thing I'm going to need to do is employ a mole-to-mole bridge. Whatever unit is there, remember, whatever unit's here is going to go right there, and whatever unit I want is going to go right there. I've got to get to the moles to oxygen gas, and I can't go from moles of water to grams of oxygen gas. I have to do a mole-to-mole bridge right here. So what I'm going to do now is cancel this with this. The relationship between moles of water and moles of oxygen gas again is 2 to 1 from the balanced reaction. So now I've got moles of oxygen gas, and it's just a matter now of converting that into grams. Whatever unit's there goes there. Whatever unit I want goes right there. I'll cancel this unit with that unit. Oxygen is 16, but there's 2 of them, so O2 is 32.00. I'll do the calculations, multiply these two, divide by this, I get 3.74. I can only have 2 significant digits here. This is 4, but I can only have 2 because I'm limited here, so I can only take the first 2 numbers. The 7 will kick the 3 up to a 4, so I have 3.4 grams of oxygen gas, and I'm done with the first problem. Okay, so remember, to go from grams to grams, I have to go through a mole-to-mole bridge. I have to go through a mole-to-mole bridge. I start with grams, go through a mole-to-mole bridge, and get back to grams for the other unit, for the other whatever it is that I'm looking for. And so I'm finished with number 1. Let's take a look at the next problem. The next problem asks, how many grams of magnesium nitrate, and they give us the molecular weight, it's 148.33, will be formed from 12.8 grams of silver nitrate, the molecular weight of that being 169.88. We've got the balanced reaction. It's a 1 to 2 to 2 to 1 mole to mole to mole to mole relationship. They're telling me I'm starting with 12.8 grams. So I know this is a gram to gram relationship. They're starting with 12.8 grams of silver nitrate. Let me circle that here so I'll remember that, and write it underneath there so I'll remember that. And I want to get to grams of magnesium nitrate. What am I going to do? Well, first of all, let me underline grams of magnesium nitrate just to remember that that's what I'm looking for. So what I'm going to do is I'm going to write what I know, 12.8 grams of silver nitrate, 12.8 grams of silver nitrate, over 1 times whatever unit is on top will go here. That's grams of silver nitrate. I need to get into the mole mode so I can navigate across this arrow. So they're telling me that 1 mole of silver nitrate has a molecular weight of 169.88 grams. So I just write that there, 169.88 grams of silver nitrate per mole of silver nitrate. Grams of silver nitrate go away. And I have moles of silver nitrate. I need to get into the correct unit, and that's magnesium nitrate, so I don't even have the right chemical. To get to the right chemical, I have to use a mole-to-mole bridge. Whatever unit's on top goes here. Whatever unit I want goes here. So in the mole-to-mole bridge, I can see that 1 mole of magnesium nitrate is produced from 2 moles of silver nitrate. So I put a 1 here and a 2 there, and then I cancel this unit with this unit, and I'm left with moles of magnesium nitrate. I'm not quite done, because what I need to do now is I need to get to grams of magnesium nitrate, so I've got one more step. So moles of magnesium nitrate up on top here, moles of magnesium nitrate here. They're telling me the molecular weight is 148.33 grams of magnesium nitrate. So that's what 1 mole weighs. And I cancel this unit with this unit. Am I looking for grams of magnesium nitrate? You bet. I'm looking for grams of magnesium nitrate. I'm going to multiply this by this, hit enter, then divide by this, hit enter again, divide by this, and I hit enter again, and I get this number, 5.58813. Now, I can only have a total of, let's see, 3 significant digits here, 5 there, 5 there. 3 will limit me. I can only have 3 significant digits. I get 5.58. This 8 will kick this 8 up. I get 5.59 grams of magnesium nitrate, and that is my final answer for this problem. All right. Let's take a look at one last one just to make sure that we've got this. Here's what it says. It says iron reacts with chlorine gas. Iron reacts with chlorine gas to form iron 3 chloride. How many grams of iron 3 chloride are formed from 12.4 grams of chlorine? So the first thing we need to do is write our balanced reaction. We've got it, okay? We've got our balanced reaction. It's a 2 to 3 to 2 mole to mole to mole relationship. They're telling me that I've got a starting place of 12.4 grams of chlorine gas. So I put 12.4 right underneath just to remind myself that's what I've got. I'm looking for iron 3 chloride. And I want it in grams, so I put question mark grams. How do I proceed? I write what I know. 12.4 grams of chlorine over 1 times whatever unit is here goes here. Whatever unit I want goes here. I know I'm going to have to go through a mole-to-mole bridge because it's a gram-to-gram relationship. I'm going from grams of one unit to grams of another unit. So what I'm going to do now is determine the number of grams that 1 mole weighs. Unfortunately, they don't give me that in the problem, so I have to add it up myself. Chlorine times 2 is going to be 70.90. Check that on your calculator. 70.90. And now I've got moles of chlorine. Here comes my mole-to-mole bridge right here. Whatever unit is here is going to go right there, and whatever unit I want goes right there. Well, what's the mole-to-mole relationship from the balanced reaction of iron chloride to chlorine gas? Well, it's a 2 to 3 relationship. So I put a 2 here and a 3 there. So now I've got moles of chlorine canceling, and I'm left with moles of iron chloride. I'm almost done. Remember, it's not a gram to mole relationship, it's a gram to gram relationship. So I've got one more step to go. Whatever unit is here is going to go right there. So we got moles of iron chloride, moles of iron chloride. Those will cancel, and I'm left with grams of iron chloride. When I add those up, 1 iron and 3 chlorines, I get this number. Check this on your calculator as well. 112.85. I'm looking for grams of iron chloride, so I'm done. Let me get my calculator out. I multiply 12.4 times 2, enter, times 112.85, enter, divided by 70.90, enter, divided by 3, enter, and the number that I get is this one right here, 13.15787. I have 3 significant digits here, 4 there. These don't count, nor does this one. Here I have 5. I can only have 3 significant digits. 13.1, the 5 is 5 or bigger. It kicks this one up. I have 13.2 grams of iron chloride, and I'm done. All right, that completes stoichiometry. We've done gram, we've got mole to mole, we've done mole to gram and gram to mole, and now we've done gram to gram in this final stoichiometric video podcast. All right, I'll see you on the next one. Thank you. Bye-bye.